Okay, this is Chapter 9, Section 2. In this video we're going to learn how to solve a system of equations using a method called elimination. Okay, so far we have looked at two different methods. One was by graphing, and you just look for where the lines cross. The first algebraic method we saw was substitution. The next method, elimination, is also algebraic, but it works a little bit differently. And here's why it's important. So here we have a system of linear equations. And the first question is, why would solving by substitution be challenging? So remember, when you're working with substitution, you want to isolate a variable of your choice, but one that's easy. Well, the problem is both of these variables in each equation, all of them have a coefficient in front of it. And so if you divide out the coefficient when you isolate, you're going to have to work with fractions. And that's not bad, but it just makes your work a little bit more complicated. So just to quickly answer, because all variables have coefficients. And if you're working with substitution, it's nice when the coefficient is 1 or negative 1, because it's easy to isolate. So all variables have coefficients. All right, but it says, or it asks, what do you notice about the coefficients of x? So in this equation, the coefficient is 3. This one, it's negative 3. Well, they're not the same. They're the same size, but they're opposite in sign. So they're equal in size, opposite in sign. So one is positive, one is negative. Okay. When this happens, this is actually quite nice. So here's how elimination works. Okay, step 1, just going to add the equations together, but we're going to add them going downwards. And notice how the equations are presented. So everything lines up. We have the x terms here, we have the y terms here, equals, and then just our constants on the right-hand side. So everything is lined up here, so we're just going to add them going down. So 3x plus negative 3x, that's just 3x minus 3x, is 0x, or just 0. Next, we have 2y plus 10y. That's 12y. Okay, here's our equals, so we'll put that there. And then we add 19 plus negative 31. Okay, so if you want to do that in your head, you can just do 31 minus 19 and then just reverse the sign. But we get negative 12. Okay? Well, if you notice, what's happened is by combining these equations together, there's no x term anymore. And in fact, we don't even need this 0. So step 2, we can just solve for y. So 12y equals negative 12. So I divide everything by 12. And these cancel to 1. And so y is equal to negative 1. Okay? So even though none of the coefficients were 1, as we hoped for in substitution, we were able to make the x terms disappear and solve for y quite quickly. Right, so solve for x, either equation will work. So I'm actually going to use the first equation, and that was 3x plus 2y is equal to 19. Okay? But we just solved for y. We know that y is negative 1. So I will replace that y with negative 1. Okay. So I'm just going to solve this equation for x. So this is 3x minus 2 equals 19. We need to add 2 to both sides, so I get 3x is equal to 21. And divide everything by 3. These cancel. It's going to run out of room here, so I'm going to write it over here. X is 21 divided by 3, which is a nice number. It is 7. So we have solved the system. X is equal to 7, and y is equal to negative 1. And if you want to double check this, you can evaluate both of the equations from the beginning using 7 for x and negative 1 for y, and they should work.